Hello everybody, I'm your host Abid Samhouri, the lead of Axon Cyber Institute. This is episode number 9 of the Navigating the Cyberland series, where we dive deep into a certain topic in the field of cybersecurity. I would like to draw your attention that this session is recorded and you can replay it later on demand. You can also access previous episodes on demand by going to the URL shown on the slide, app.livestorm.co/axon-technologies. The topic of today's session is going to be conducting OWASP-based web application security testing. Before I start, I would like to ask if you can hear my voice clearly and you can see the screen clearly. Just type so on the chat. Great, thank you. Thank you guys, thank you. So the agenda of today's webinar is going to be as follows. We're gonna talk about the OWASP organization, the OWASP community, which stands for Open Web Application Security Project. And then we will talk about one of their projects, which is the testing guide, the Web Application Security Testing Guide. We will go through all the technical phases. There are around 11 or 12 technical phases, which we will review so that you get an understanding of each phase and how you would conduct it in real life scenario. And then finally, what you need to do in order to present your testing in a report that is OWASP according to the OWASP standard. The OWASP testing guide is very, very comprehensive. It's very, very deep. And I believe every phase of it requires sessions and sessions in order to master it. So you can think of this webinar as an intro to the entire OWASP framework. So let's start by talking about a background of OWASP. OWASP stands for Open Web Application Security Project. It's an online community. It's an online, they have an online community. It's a non-profit foundation or non-profit organization, was established in 2001. It consists of many experts in the field of cybersecurity and particularly web application security. And over the years, they have provided so many resources, tools, conferences, trainings, videos, tutorials, etc. And they have even developed some tools and projects that will help people and will help even web application developers, even those who are not in the field of cybersecurity, they can still benefit from what OWASP has provided. So they benefit both cybersecurity experts or cybersecurity specialists, as well as web application specialists and web developers. Some of their projects include the Attack proxy, ZAP, which is a very, very popular open source tool. It's an intercepting proxy. Some of you who are familiar with Burp Suite, the Attack proxy is very similar to Burp, and it is written in Java, available on Linux, Windows, as well as Mac. You can go to their website, owasp.org, and you can download this tool. They have also the Web Security Testing Guide, which is the one we're going to talk about. It's a framework. It's a comprehensive, practical, and technical framework for doing penetration testing and security assessment. They also have Mobile Security Testing Guide, just like they have the first Web Security Testing Guide. Over the years, mobile applications have taken over and they became very popular. And also mobile penetration testing is somehow a branch of web security penetration testing. In other words, many of the techniques that are involved in web application security can be applied to mobile app security as well. And in addition, there are specific details to the mobile frameworks. For example, their testing guide can give you information on how to assess, let's say, Android versus iPhone or iOS platforms or iOS-based applications. They also have the Software Assurance Maturity Model, the SAM, which is a framework for testing the maturity level of software or the assurance level of software. So it's a guide of our questionnaires you can go through and then see which part is applicable, which part is not applicable, which part is done, which part is not done. So you can know if the software that's being developed is mature in terms of its assurance. They also have what's called OWASP Top 10. This is like a guide of top 10 vulnerabilities that exist in web applications. The researchers at OWASP, they have done extensive research and assessments of various web applications, and they have come up with top 10 vulnerabilities that are most found in web applications. So if you do not want to do a comprehensive testing, at least you can do a test of the top 10 vulnerabilities. So what is this testing guide that they have? It is a very comprehensive practical and technical guide to assess web applications. And they provide you with the background of the vulnerabilities, how you can go through it, how you can find it, discover it, and how you can perform the assessment in a black box and white box, and whether you have access to the source code or not, and also what tools you need to do, and how to remediate also that vulnerability. So it's very comprehensive. And according to OWASP, one of the biggest mistake that developers do is they put security testing kind of at the end of the software development lifecycle, which is something that is not really a good security practice. What OWASP recommend is to put security testing embedded in each or integrated in each phase of the security development lifecycle. As you can see in this image here, the first phase is design, and then develop, deploy, maintain, and define. This is kind of the typical software development lifecycle. However, if you do not do security testing in each phase as you build your software, the more you go into the phases, the harder it becomes to fix a vulnerability. So if you have reached to the deployment stage and maintenance stage, and then you discover a vulnerability, to correct that vulnerability, it requires a lot of time. So that's why it's better to integrate security in the beginning or in each phase as you develop it. And as I said, like the technical guide in each aspect of it, it tells you how you would test this particular aspect in a black box way, gray box, and white box. In white box, as you all know, you already have you already have access to the source code, and you can view it inside out. While in a black box, you have no knowledge, you have no information, and a gray box kind of in between. So black box kind of resembles real world hackers, while white box resembles, let's say, the developers or the insiders. So the OWASP testing guide gives you in each section how you would perform a black box testing and white box testing. So it tells you, for example, cross-site scripting, how you would discover it, how you would exploit it in a black box way, and then how you would discover it and exploit it in white box ways. And even some parts, because of its comprehensiveness, some parts of the guide are more relevant to white box testing. So there are certain, like if you are doing only black box testing, maybe there are a lot of sections in the guide that might not fit into your assessment or penetration testing. So these are kind of the phases of the OWASP testing guide. The first phase is the information gathering phase, where you kind of profile the application, and then you have to test the configuration and deployment setting of the web application, and this also includes the web server that is hosting the application. Then you move on to the identity management testing, which is everything related to the usernames and user identities, and then to the authentication phase, the testing of the authentication. This all has to do with the password and how users are authenticated. And then the authorization testing, which is everything has to do with the privileges that the users have after they have logged in. And then the session management testing, and you would test how the entire session is maintained from the login to the log out, and how it is packaged, bundled together, how it is managed by the web application, whether it can be broken, hijacked, etc. After the session management, there is this phase about input validation. Like in the information, in the first phase, you would gather, you would profile all the inputs, all the entry points to the application. And then in this phase number 7, you do assessment of the input validation. In here, you have all sorts of things like SQL injection, command injection, Ldap injection, all sorts of injections. After that, you assess the errors. How does the web app handles errors? Sometimes error reveal information. Does it properly handle error or not? Then you would assess for cryptography. This is if the web application is using SSL, HTTPS, everything to do with the SSL and the TLS tunnel, and the certificates goes into this phase. Then you would assess the business logic. The business logic is everything that is not discoverable automatically, that has nothing to do with the actual vulnerability in the code, but how the process itself, the legitimate process, is being implemented, and whether it can be circumvented in any ways. Then client-side testing. There are vulnerabilities that do not affect the servers, but affect the web browser of the user that is browsing the web application. And then finally, the API testing. If there are any REST calls or any APIs between the applications, you would assess that calls as well. So let's go into each phase by itself and discover and talk about it in more details. So let's talk about the information gathering. The information this is the most basic and most important phase in any penetration testing, whether it's web application, mobile application, or even network penetration testing. In this phase, you have to know what web server is being used, the software, the version. Is it Apache 2.2.4 or 2.2.2? Is it IAS? Is it Nginx? So you have to profile the web server and its version. And then after you have done so, you have to discover what type of application framework is being used. This is the application level now that is hosted on the web server. This includes things like ASP.NET, PHP, Apache Tomcat, Java Platform, Java Applet, Java Beans, all of these application frameworks that are being used. You have to assess them. You have to profile them. Is there a content management system that is being deployed on the application, like WordPress or Joomla or Drupal? So all of these, you have to discover them either through some scanning tools or through like intercepting the request and the responses and checking the headers. They can be sometimes revealed on the headers, on the HTTP headers. And then you have to review the source code. Always make it a habit when you do any web application assessment on every page, view the source code and check any scripts that are there, check the forms, the inputs, the hidden inputs. Also check the comments. Sometimes developers leave like strange comments that can reveal information. Figure out if there are multiple web applications being hosted on the same server. Can you profile them? Can you know where they are? For example, sometimes web applications are being separated by port numbers. So on the same domain, on the same server, you have one that is hosted on, let's say, port 8080. The other one is hosted on port 8888. Sometimes administrators put different applications using different subdomains. So they might have like app1.example.com and they will have app2.example.com. So each application has its own subdomain. Sometimes they are being hosted using different subdirectories. So example.com/app1 versus example.com/app2. Also try in this phase to list the content of robots.txt. This is a file that is like by default, it is there, and it can be edited by webmasters and web administrators to actually exclude certain folders or certain directories from being indexed by search engines. And sometimes developers think if they disallow certain directories or exclude certain directories, the directories become like safe or inaccessible. So you might enumerate certain directories on that web applications that are otherwise inaccessible directly from the main page. Then this is very important step you have to do in this information gathering phase, which you have to profile and map all entry points. You have to map all input fields, and input fields generally include or mostly include the forms input, or including hidden ones, and usually form inputs travel in post requests, and also some of them in URL parameters using get requests. So you have to profile all of these, because later on in phase number 7, we have input validation. We're going to take all these entry points and start fuzzing them for other types of vulnerabilities. Then profile all cookies as well, see all cookies, and profile all headers that go in the request as well as that are received in the response. Here are some of the main tools that are being used in this information gathering phase. You have Nmap, wget. Nmap is a popular port scanner, and it can also detect if there are like multiple web applications instances on the same server. Also wget, so you can get the robots file. HTTPrint also can profile or can fingerprint the web server, and the Zap proxy, which is the project developed by OWASP themselves. And Zap is implemented as intercepting proxy in the middle. It can show you all the requests and the responses at the come and go during the navigation of the website. Also Burp Suite as an alternative to Zap proxy. And by the way, Zap proxy is not only for this phase, it can be used for all the phases. So Zap proxy and Burp Suite are like the kings of web application security testing tools. So you will use them from beginning to the end. So after you finish the first phase, now you jump into the configuration and deployment management testing. This is a phase that has to do with testing the underlying configuration of the web server itself. And the tests include really simple things, but they have a huge impact on your assessment. You have to do a typical vulnerability scanning of the web server. Now, even though this is like a system scanning or a network scanning, it will help you discover vulnerabilities on the server level that might affect also the web application that's being hosted. So a scanner like Nessus or OpenVAS, if you are looking for an open source, or you can go to Qualys or other commercial scanners, will help you in discovering the server level vulnerabilities at the configuration level. Then try to browse for files with different extensions. For example, if there are files with PHP extension, ASP extensions, try to make sure that all of these files get compiled on the server, and none of these files reveal their code to the client. So any server-side scripting extension must not be displayed on the web browser, must be executed on the web server. Sometimes you might find during your assessment that under certain circumstances or in a certain directory, a PHP code gets revealed. So this is part of the configuration testing, because it's a setting on the web server itself. Also, sometimes webmasters and web administrators, they might have a backup of the website or an old backup of the website that contains outdated information that is no longer there but are sensitive. and then they leave that backup file accessible from the website, even though there is no direct link to it. But if you can figure out or try to brute force its name, you might access it directly. Another thing in the configuration deployment phase is to test for admin interfaces. There are a lot of websites, like when you go to the home page and you start navigating here and there, you will never see like a link to the admin dashboard. However, if you can brute force these names and if you can guess them, you might get access to them. So /admin/administrators are the most common admin interfaces links. However, you can also try to crack or brute force also other names. Try to enumerate all HTTP methods and to profile them and write them down and check which ones are enabled and which one are not enabled. Do you see delete and put? Delete and put are also HTTP methods that are very, very dangerous if exposed publicly. Also, trace has a medium risk vulnerability if exposed publicly. It can only reveal information but will not allow to change things. So try to profile the HTTP methods. If you have done so, you have completed, in a nutshell, the second phase. And now we go to the identity management testing. The identity management testing has everything to do with the username itself. So like when you go to the Facebook, you have a username and a password. The username is your identity, and this part of the assessment includes everything that is around the username, everything around that identity. So when you try to do the assessment, number one, try to figure out if there are multiple roles on that web application. And by role, we mean groups with different privileges. For example, you might have normal user group, administrator group, operator group, advertiser group, and so on. Try to figure out what your client, what your target is implementing on their web application. What roles are there? Sometimes if you are doing like white box testing, this can be easy by reviewing the source code. But if it is black box, you might need to do a lot of trial and errors. Sometimes the roles are revealed in cookies or token fields or post data. For example, you might see things like role equal admin, or is admin equal true or false. These are clues to what roles are there. After having defined what roles exist, now it's time to check how the registration process looks like. Does your target give people the ability to register for themselves, or does it require like administrator on the background manually registering for people? If there is automatic registration, if the user is allowed to register, is there somebody vetting or reviewing that provisioning before the user account is valid or not? Can people like register with multiple identities, or is it restricted to one identity only? What is the permission that is given? What are the different roles? Like when you register, what role can you assign your account to? Also, what proof of identity is required? Sometimes only an email address. Sometimes the date of birth is also required. Sometimes the physical address and the PO box, for example, is required. All of these information is important so that you assess if that web application is high profile, for example, then it should require more proof of identity. If it is like a public for anyone, for social media, then probably the email address is the only proof of identity. How does the web application and the administrator of the web application ultimately verify those identities? Is there such a verification process or no? All of these steps are important. And then you have to check how the creation of the account and also deprovisioning of the account take place. Can an administrator provision other administrators or just users? For example, sometimes you have like a domain administrator or a global administrator who provisions like normal administrators, and then administrators can provision normal users. Sometimes administrator can also create other administrators account, like on the same horizontal level. Also, can an administrator or a normal user deprovision themselves? Like, or does it require somebody from a higher authority to deprovision their account? All of these are also important. What happens when somebody deletes their own account? What happens to their files, to their data? Are they automatically deleted? Are they transferred? Are they backed up? You have to take into account all of these steps. Then try to see if you can enumerate usernames. Sometimes web application can give you clues if a certain username is valid or invalid. For example, if I type an invalid username without a password, the application might tell me this is invalid username. Sometimes it tells me it's either invalid username or invalid password. So if it tells me whether the username is invalid, I can have a list or a dictionary of usernames, and then I would try them one by one. And whenever I get invalid username, I would know that this username does not exist. And every time I get a valid username but invalid password, I know that this username actually exists on the system. So in this way, I can enumerate the usernames. I also can check for the policy of creating usernames. Sometimes organizations have policies like first name dot last name, like in the example seen here, John.Smith, for example. Sometimes it's the first letter of the first name, like J, and then dot, and then the last name is Smith. Sometimes it's the first name, the first letter of the first name, first letter of middle name, first letter of last name. Like if the guy is John David Smith, he would have a username of JDS, for example. So try to map out the policy and what is the scheme of creating usernames. So the identity management testing is everything that is related to usernames and to the policy of creating usernames. Now you move on to the other aspect of identities, which is the verification of those identities, and that is called authentication. And here we are talking about password, because the most common authentication method is password. We all know this, and passwords can be cracked offline or online. They can be captured by man in the middle. So this section is about the strength of the password, whether it can be captured, cracked, and features around password, like the password reset feature or functionality, the remember me feature. Are they secure? Are they not secure? And how can you assess them? So the first thing you need to do in this phase is try to see if the password is sent in a clear text. If it can be sent in a clear text, then it's captured and sniffed. If not, then try to see if you can break the HTTPS or try to break the encryption by doing SSL man in the middle, for example, and check the SSL, the strength of the SSL certificate and the strength of the SSL tunnel itself. Because if you can break it, you can also sniff that password. And there is a certain phase, which is phase number 9, that is fully dedicated to SSL and the cryptography testing. Also in this phase, You will test for default credentials. You will test for like admin password, administrator pass 123. All of these default credentials that sometimes come built in by vendors. You will try to assess them. If the package you are trying to assess is well known by a certain vendor, then you can search online for the list of their default credentials. If it is in-house developed, then you can try common default credentials used by people. Also try to test for lockout mechanism. Does this web application has any way to lock out the account if there is a certain number of incorrect attempts? So what you would do here is you will try multiple incorrect attempts with correct attempts and try to see if the account gets locked out after 3, 4, 5, or 10 attempts, or even there is no lockout at all. And even if there is a lockout, what happens after the lockout? Does it unlock automatically after a certain period of time? Like let's say after 5 minutes, 10 minutes, 20 minutes, half an hour, 1 day? Or does it require an administrator to manually unlock that account? So you have to take all of these aspects into consideration when doing the lockout testing. Try to check if there is any way to bypass authentication. And there are multiple ways to do that. One way is to try to access a privileged page directly. So you'll have like a test account, and then you will gain all the URLs and all the access, the direct access to the pages, and then log off and see if you can visit those URLs and those pages while you are logged off. Sometimes if the web developer has not taken their authentication scheme properly, you might find yourself like accessing a certain privileged page without authentication. Then there are other methods also to check for authentication bypass through injection and session hijacking. Now, these are like related to other phases, but they overlap also with the authentication testing. Then try to assess the remember my password feature, whether it's a strong way or not. Like in any remember me feature, what needs to be done correctly, first of all, it is not a security practice to click on remember me. But for ease of convenience, in case you need to implement it, the correct way is when the user clicks remember me, there has to be a token that is secure and that is random enough, unpredictable, that is generated and saved as a cookie. The password itself should never be stored in any way, neither in a cookie or the web storage, not even encoded or hashed. So the password should not be stored. What should be stored is a token that is generated once. So it gets destroyed after you log off. Test the browser cache. Sometimes you might access your account, access the privileged dashboard, and then when you log off and then you hit the back button once or twice, you might find yourself visiting those privileged pages again and revealing the sensitive information that was on them. This is not the right way. What you should see instead is when you log off and then you try to go back, then what the web app should present you with is the login page, not the actual pages that you have visited before you logged off. Check the password policy as well. What is the length of the password? Which characters are used? The combinations of these. Is there a password policy in the first place? And so on. If you are doing a black box testing, try to create accounts yourself and see if weak passwords are accepted. If you are doing white box testing, this should be easy in viewing the source code. Also, security questions. Look at the question, for example, like what is your first pet's name versus what were the last 4 digits of your childhood telephone number? We all agree that the second question is a little bit harder to actually figure out by a social engineering hacker than the first question. So try to see if the web application has weak questions, easily guessable, and you have to report them to the developer. When the questions are answered, will it directly unlock your account, or will it directly take you to the login page, or will it send you like activation link by email address? So of course, sending a link through the email address is the right way, it's the more secure way. The reset password. How does the web application allow user to reset their password? Does it require only their email address or email plus security questions? Is it done directly on the website, or like there is like a link sent to the email address? All of these you have to take into account. Can an administrator reset the password of a normal user? Yes or no? You have to figure out that. And then you have to see if the password is sent on alternative channels. What does that mean? Sometimes the web application can be accessed like using web browser and through a mobile app. And then the mobile app, for example, might use HTTP, while the web browser version would use HTTPS. So in this case, even though you cannot intercept the password of a user through the browser, but if that user is browsing or is accessing the app through their mobile phone, their mobile app, then their password is compromised. So you have to check what alternative channels are there to access the same web application. So after authentication, after the assessment of the password and everything that revolve around the password, we now move on to the authorization testing. This is the authorization phase. Everything has to do here with the privileges. Okay, so you have logged in, people have logged in, the administrator is logged in, normal user is logged in. What the privileges does each one of these get after logging in? The privileges or the assessment can include things like, can you access a file directly on the system from your privilege? Can you access someone else's data? Can you perform forbidden transaction? Like for example, if you are talking about a banking account, can you perform transaction or money transfer from someone else's account? There is something on the authorization testing or the privilege testing called directory traversal. In directory traversal, you try to jump outside the web root directory and try to access files that are on the system that are otherwise inaccessible if you are not logged in. So, and this attack is normally called the ... attack, as you can see here, because it involves the 2 dots /, and if you insert multiple ... characters and then append it with a file name, you would actually traverse the system directories. And we are talking here about not the web server vulnerability of directory traversal that was a long time ago found in IIS and Apache and have been patched since then. But we are talking about directory traversal that are due to web developers' errors. So sometimes like a Java developer or ASP.NET developer would not like sanitize the input, and directory traversal becomes allowed or vulnerable. So you can access files outside the legitimate web root directory. Also, try to do two different types of testing or bypassing authorization, horizontal and vertical. In a horizontal assessment, you log in using a certain normal account and you try to access files of other users who are on the same level of privilege as you, like you belong to the same role. So if you are a normal user, you try to access another normal user's data. In a vertical assessment, you try to go upward by gaining access to files that belong to a higher privilege user account. So if you are a normal user, try to access administrators' data. And there are different ways. You can play with the URL, you can tamper with post data. So post data, the URL is the get method, and post data is the post method with generally forms. Aside from accessing files, try to check whether you can increase your privilege and become of a different role. So if you are a normal user, can you become an administrator? Can you change the role? Can you change the group and the privilege level that this user has? Also, there is something called insecure direct object reference. Let's take this account, the example here. We have this URL, foo.bar, some page, question mark, invoice equal 12345. Let's say you have a privilege to access that invoice and you see it on the URL. There are other invoices with different numbers that are inaccessible to you, and you don't have privilege to view them. Supposedly, you don't have privilege to view them. However, if a hacker manually tampers with the invoice ID, they might be able to view them. So try to manipulate these numbers and see if you can directly access objects. So after the authorization, so we have completed identity, authentication, authorization. Those three phases that we have covered, 5, 4, and 3, are somehow related. It's username, password, and then the privileges. Now we are talking about the session management. The session management is how does the server maintain the entire session of a user account from log in to log out. And everything in between that happens, we know that somehow the web server, the web application, needs a way to track user activities from log in to log out without asking them to supply username and password with each request. And this is the concept of a session. And the most common way is through a token that is randomly generated and saved as a cookie. Your role now is to test this token. Sometimes it's called token, sometimes it's called the session ID, sometimes it's called the session cookie. So your role is to figure out the strength of this token. You might generate a huge number of cookies. By sampling them, try to see their length. Do they have like a certain fixed length? Do they have a variable length, each one? Is the content or the actual ID itself fully randomized? Is it a hash of some sort? Like some session IDs are MD5 hashes of some data. What could be the content of that cookie? If it is like a SHA hash, for example, it's a SHA hash of what information? So find out if the cookie is permanent or impermanent or transient, whether it has a lifetime, whether it expires after a certain period of time. Once you have gathered all this information, try to see if there is a pattern in the cookie, okay? And based on this pattern, try to figure out if it is predictable. If you can predict, if you figure out the formula of the cookie, then you can predict the next cookie that will be generated by the server for other users. Or if you gather enough information about a client or about certain user, you can figure out their cookies. For example, some systems, they generate sequential cookies, and this makes them very prone to prediction. Can you brute force it? Is it crackable? Remember, in session management, anytime you manage to grab someone else's cookie, it's a game over. You have access to their account. Next, try to see what attributes are attached to this cookie, to this session ID. There are different attributes to each cookie. I'm going to list here 4 of them. The secure attribute, this means the cookie is only transferred over HTTPS and it will not be transferred over HTTP. So this is a good sign. It's a good attribute. Try to see if it is implemented or not. If not, recommend it to your client. HTTP only means that the cookie is not accessible from JavaScript. It can only be transferred on the wire. So this generally would prevent cookie stealing through cross-site scripting attacks or JavaScript attacks. Try to check the domain and the path of that cookie, the scope. Where does it apply? For which pages? Try to check also the expiration time. Then we have a vulnerability called session fixation. Session fixation is when the hacker can fix a cookie for a user to use, so that when that user logs in using that cookie, that fixed cookie, the hacker already knows the cookie in advance. This is session fixation. And this is a vulnerability. If you see that while browsing the web application, your client generates a cookie for you before you authenticate, and then after you authenticate, it uses that same cookie again as a session ID, then that application is prone to session fixation. Then test for exposed session variables. Try to see if the cookie is exposed over HTTP or if it is sent additionally in the URL or as a token somewhere else during the communication with the server. Then the OWASP guide asks you to perform cross-site request forgery, the Csurf attack. And this is an advanced attack. Okay, I usually explain the Csurf in a 3-hour session in other courses. So, but briefly, in Csurf attack, the hacker forces a client or another user to perform a transaction unknowingly. So the hacker would craft a certain URL, would craft a certain malicious website, and then ask the victim to come to this website or to click on that URL. The victim unknowingly would click there, and then their browser would perform a transaction on a vulnerable website, and they have no intention of, and they are unaware of. And that transaction would actually help the hacker. For example, I might craft, if a bank application is vulnerable to Csurf, and then I might entice, let's say, Alice to transfer money or funds from her accounts to the hacker's account, unknowingly, without her awareness or knowledge. This is what Csurf attack. And the best way to mitigate that or to check that is when you are doing your assessment, try to see if there are sensitive transactions, like let's say resetting your password, or transferring money, any sensitive transaction, and see if the only authentication that is associated with this transaction is the same cookie that is used for the whole session. If so, that means it is vulnerable to Csurf. If there is an additional factor, such as a token, a Csurf token, this would limit the Csurf attack. In the session management testing, you also need to test for logout. Is there a logout mechanism? Is there a timeout of the application? Like after 1 hour of inactivity, does the client application logs you off? Does it allow the user to log off? After you log off, what happens to the cookie? Is it fully destroyed? Because if not, then it can be reused, and if reused, then you can access the same account again without re-authentication. Session hijacking is basically when you compromise a cookie in any of the previous method, whether by sniffing it or by fixing it. And also test for session puzzling. Session puzzling is when a certain cookie or a session ID or a token serves more than one purpose. Okay, it is used for authentication and it is used for other activities on the website. Now, if those other activities are unprivileged and it can take place outside the login or outside the authentication, that means the same session ID now is being revealed while the user is logged in and the user is not logged in, which means, again, stealing a cookie is applicable in this case. Next, we move on to the input validation testing. And this is probably the largest phase in the OWASP. And the most severe vulnerabilities in web application exist in the input validation category. Like all things like cross-site scripting, SQL injection, command injection, Ldap injection, XML injection, server-side include, remote file inclusions, all of these fall under the input validation. It is the largest section, and it requires a lot of knowledge, a lot of skills, and a lot of time to actually perform in a thorough manner. So what is input? Input is any user-supplied data that is fed into the web application. You have a form that asks you, as you can see here, that asks you for first name, last name, email, and so on. All of these are inputs. The user has control of what he types, and those inputs are being sent to the server. Now, all input validation requires, or inputs require that the web developer perform a sort of filtering of those inputs before any processing. And a lack of proper filtering means the hacker can inject malicious inputs into those fields, okay? And depending on where the input is used, ultimately, depending on that, we have a class of vulnerability. So the input can be ultimately be used as part of SQL statement. It can be used as part of Ldap. It can be used of XML file, and so on. And based on where it goes, there is a class of vulnerability. So if that input that you insert on the field gets later on published or later on is sent back to the browser, then we have the possibility of cross-site scripting. So what you would do is, instead of entering the required information, like let's say telephone number or username, you would insert a piece of JavaScript. And this JavaScript would go to the web application. Later on, it will be downloaded to the browser. If it gets executed as JavaScript, there is a vulnerability of cross-site scripting. The same goes for SQL. If that input is ultimately gets inserted inside an SQL statement without sanitization, without filtering, then there is a possibility of SQL injection. We are all familiar with the typical example of SQL injection, where you have the select query for username and password, and then the hacker can enter something like one quote or quote one quote equal quote one, as you can see here in the red, and the password, the same thing for password. And this alone would actually allow an authenticated user to actually log in as the first user in the database, typically the administrator. The OWASP guide will give you instructions on how to perform SQL injection, and then it will give you guide on how to build SQL injection that are tailored to specific vendors. For example, if the SQL server is Oracle, then the query or the injection will be a little bit different than if it was MySQL or Microsoft SQL Server or Postgres, because each one has its own syntax. So what one vendor might use, let's say, single quote, another vendor might use double quote, for example. If the input is part of Ldap query, then we can test for Ldap injection. As you can see here, we have an Ldap query that again tries to read the username and the password and try to check if the username and password are correct. And if there is no sanitization, the user can insert, or the hacker can insert, like specially crafted username. And this specially crafted username, when embedded ultimately inside the Ldap query, it will cancel the verification of the username, and then it will even cancel the verification of the password, so that the password can become anything, and then the username becomes like a searching for username equal any, or username equal any, which is always true, and then the hacker will log in without knowing the password. If the input becomes part of shell or system command, then we can test for command injection. As you can see here in this graph, which is a snapshot from Moteliday, we have a functionality on the website that through which we can do NS lookup or lookup DNS. So we enter like an IP address or a host name, and then look up DNS. And then the code on the PHP is as follows. We have shell _exec. This is the built-in function to execute something on the shell. We are executing NS lookup command appended by the target host, which is the domain we have inserted on the text box. Now, what happens if there is no filtering, and then after the domain name, like cnn.com, I insert something like semicolon, and then a shell command like uname or ls or pwd or whatever. Then in this case, my command is going to be executed. And as you can see here on the last arrow, the last red arrow, we have managed to execute the uname -a. Another test we can do is XML injection. If our input becomes part of an XML file or XML entries, then we can manipulate and inject XML queries or XML entries. As you can see here, we have an XML entry called add to cart. If you check the first URL, example URL, we have add to cart.php and then item equal 5, quantity equal 1. This will be translated to an XML entry in a file as follows: add to cart, and then inside the tag, we have the ID equal 5, and then the item price 50, and this is built in the system, so it's not supplied by the URL, and then quantity 1. So in this legitimate request, the user is buying one item that costs $50. Now, if this is prone to Ldap injection, the hacker can insert something like this. He can insert quantity, the ID, the item ID 5, and then he would append it with his own XML entries, the item price 0 and the quantity 10, and then in order for the entire file to look legitimate, he would add another entry with item ID 5 and the quantity 0. And the result will be in the file, there will be two entries in add to cart. The first one, we have ID 5, which is the item to be bought, with the price 0 and the quantity 10. And the second entry, same ID 5, but with the original price 50, quantity 0. So you can imagine here what the hacker has done. He has bought 10 quantities of that item for $0. So this is about the input validation. There are other types of input validation testing. I cannot go through all of them in here, but we have covered the most important or significant sections of the input validation phase. Then we need to assess for error handling. Errors are ways of the system to respond to certain exceptions. And the errors oftentimes reveal various information about the systems, the internal systems and services, and so on. And if the developer has not written code to handle those errors ultimately gets thrown at the user, and the malicious user can actually gain some information about the system. He might know certain IP addresses, certain domain names, certain services, certain APIs. He can even perform some denial of service from these errors if not handled correctly. So in your assessment, you have to trigger errors, okay? You have to intentionally trigger errors by doing like strange things, like searching for non-existing files, for example, or try to mistype a certain file name, or try to request folders but no file name. And ultimately, you can fuzz every single input that you see using Zap, and try to gather all these errors and try to see what information being revealed. And ultimately, in this phase, whenever there is an error that is getting revealed, the recommendation to your client is to actually handle the errors at the server side and generate a custom made page to the end user instead of generating the actual system error itself. Now, you go to the cryptography testing. This is everything related to HTTPS and the underlying SSL TLS tunnel. This is by itself a complete assessment. And I have done a webinar last year. It's webinar number 1 on how to perform SSL assessment, TLS and SSL assessment. You can go to it. It's a 2-hour webinar fully in doing SSL assessment. But briefly, what you need to do in this phase is you need to know what version of SSL and TLS is being used. We have SSL version 1, SSL version 2, version 3. We have TLS 1.1, 1.2, and 1.3. Now, the most secure until now is 1.3, of course. 1.2 is secure. It is still acceptable. It's not completely vulnerable. However, SSL version 1, 2, 3 are completely outdated. TLS 1.1 is also outdated. And each one of them has an associated list of vulnerabilities you need to know about, like Poodle and Oracle and some other vulnerabilities. And you need to make sure, like when you find one of these outdated protocols, to report to the administrator to actually implement the latest version of TLS. Try to check the length of the keys, the RSA keys or the symmetric keys like AES, for example. If it is RSA, is the key length 1024? Is it 2048? Or sometimes it's 4092, for example, or 96. Try to see the length. And RSA 1000 is outdated. Okay, RSA 1000 is outdated. It should be 2048 or 4096 minimum. Try to assess the hashing algorithm. MD5 is also outdated. So if you see it in use, recommend that it has to be changed. SHA-1, SHA-2 are acceptable. Also try to check and verify the certificate itself. When does it expire? Is it expired already? Try to check if it is self-signed or is it signed by a CA? Is the CA a trusted authority like GoDaddy and VeriSign? Is there any unencrypted channel? For example, as I said, you might have a certain web application using HTTPS. However, there is a mobile app to the same application that does not use HTTPS. Okay, so try to figure out if there is any unencrypted channel. Now we go to the business logic testing. Business logic testing or business logic flows are flows in processes that are legitimate. So it's not a vulnerability or a bug or a flaw in the code itself. And that's why it's very hard sometimes to detect them. And they cannot be detected automatically by like automated scanners. And you have to manually search for them and try to actually figure them out. For example, if there is an e-commerce website where you can buy stuff and there is a way to actually change the currency from dollar to Lebanese lira, for example, and the system does not verify this after it thought it was getting it to the dollar, then this is a business logic flow. It's not an injection flow. It's not like code injection or cross-site scripting. It's a business logic flow. We can look at this example together. Let's say there is an e-commerce website where users can order carpet, okay? And people can go online, select their carpet, they choose the size, they make the payment, and then everything is being verified by the front end, and everything is valid, and then the purchase order is being registered. Now, once the carpet is now purchased or being paid for, the system now has two paths. If it checks if the carpet is in stock. If so, it will be shipped automatically from the original warehouse of the e-commerce website, from the original business warehouse. If it's not in stock, it's gonna call like a partner and then ship a similar carpet from the partner's warehouse. Now, what happens if an attacker manages, like the carpet is in stock and it is shipped from the in-house, but the hacker manages to send a call to the partners and ship another carpet from the partner's warehouse? This is a business logic testing. So in a business logic assessment, you have to sit with the developer and you have to see exactly what the application is intended to do. What is its legitimate purpose? What does it accomplish? And then try to see ways of circumventing that logic of the business process itself. Then finally, we will talk now about the client-side testing. The client-side testing is everything to do with the web browser itself. It's not the web server, it's the browser. However, the attacker utilizes a vulnerability in the web server to harm the client. So the web application that's being deployed will be used to harm your clients. And this can cause reputation loss. Many clients can lose trust of the client's website because of the attack. So that's why it's very important to mitigate those vulnerabilities, even though they do not harm ultimately your own web server. Cross-site scripting that we have discussed are a form of client-side attacks, because in cross-site scripting, the JavaScript ultimately is being deployed to the web browser as being executed on the web browser. Okay, similar to cross-site scripting is HTML injection and CSS injection. The hacker here finds a certain input field that ultimately gets transferred to the web browser of the user, and then he would inject HTML code and cascaded style sheets, and then those codes or a snippet of code ultimately are executed on the web browsers of the users. Another famous client-side attack is a clickjacking attack. And I believe this is the last attack we'll talk about here. In a clickjacking attack, it involves getting your target web application, okay, your target web application in a frame that is completely invisible, and then you would put that invisible frame in front of your malicious website, and then people think, the victim thinks, they are browsing that malicious website where it says you have won the lottery, for example, click here to reclaim your money. And then they think they are clicking on the button that says reclaim your money, but in reality, they are clicking on the target web application button that is invisibly put on top of the malicious website. And they are actually performing a transaction on that target web page. So as you can see here on this image, the user or the victim thinks he is clicking on the green button, which is invisible, by the way, so it's totally invisible. But ultimately, he thinks he's clicking on the red button, but ultimately he's clicking on the pay button that is the green, because the green is totally transparent, invisible, okay? So he wants to click on the red one, but he ends up clicking on the green one. Here is a more better example. As you can see, there is the OWASP website with a button, and this is the background frame, and then on top of it is a transparent frame that transfers money. It's a wire transfer, and then the victim thinks he's clicking on OWASP, but ultimately, actually, he's clicking on transferring money. The solution to this, what you need to do, is try to check if your client target has implemented the X-frame options header. The X-frame options either allows your website to be embedded in an iframe by an external, by a third-party website, or this allows anybody to embed your website in an iframe. With a header like X-framed options deny, your website will never be inside a frame. And this attack cannot succeed unless you can iframe the target website. Okay, again, there are other steps inside the client-side testing, but because of time, you cannot really go through them. So let's talk about the final piece of today's session, which is how would you present your report? Your report should be comprehensive, and the OWASP has full section on how your report should look like, okay? But basically, you have three main sections in your report. The first one is the introduction and contains things like table of content, the theme, the scope of the assessment, the timeline, the disclaimer, and then executive summary, simply a summary for higher management, and then the findings. And the findings, you can present them in two sections, in a summary way and a detailed way. The detailed way has to include all the items seen in the table on the right. So for each vulnerability, you have to include the reference ID. Okay, generally, this is the reference ID of the step of the OWASP itself. If you go to the OWASP website and you open the testing guide, you will see that each section of it has an ID. Okay, so Sql Injection has an ID, Ldap injection has an ID, error handling has an ID. So you include that ID and the title of it, as I'm showing here, this example testing for stored cross-site scripting. And then you will mention the likelihood of the vulnerability, the impact, and the risk. So likelihood, it is so easy to exploit this vulnerability. And the impact would be something like cookie stealing. The risk can be high, medium, or low. Since it is easily exploitable and the impact is high, then the risk is high. And then you have to include a detailed description of the vulnerability. What did you find during assessing this particular step? Okay, and with a proof of concept, how you would perform this attack, and what is the remediation? Always you have to provide a remediation and what the developers need to do in order to fix this vulnerability. And then finally, any resources or references. The older version of OWASP used to have a template that includes all IDs of all the steps within the testing guide. But in the most recent one, this template doesn't exist, and you don't have to abide by inserting every single reference ID on the OWASP guide, but the most applicable one instead. I have done this webinar. I'm done with all the material I wanted to present today. I would like to thank you very much for being with me and for listening. If you have any question right now, you might type them on the chat, or you might contact me on the email shown on the screen, aws@axontechnologies.com. As I said, there are recordings, and you can view the recording at app.livestorm.co/axon-technologies. Thank you again. If there is no more question, thank you all. Thank you. Have a good day and see you in future webinars.